Let's do a slightly trickier problem that introduces a new idea. We want to consider what happens when we have repeated elements. So far, we've considered, hey, how many ways can I arrange n distinct objects with no repetitions, n different things? What if instead there are actually some repetitions? So in order to motivate this, let's consider the following problem. How many ways are there to rearrange the letters of the word selfless? Selfless. So selfless has a total of 8 letters in it, but, and this is the key point, not all of those letters are different. There are 3 instances of the letter S, 2 instances of the letter L, 2 instances of the letter E, and just 1 instance of the letter F. And so this means that our answer isn't just going to be 8 factorial. So 8 factorial was what the answer would be if all of these were different, but they're not different. And that means we're going to have a different answer. To see why, notice that, let's just start with the word selfless itself. I'm going to write it down twice. But what I'm going to do is I'm going to swap the 2 E's. So here I'm going to label them E1 and E2, and I just relabeled them, so I swapped them around. So now I have E2 and E1. Okay, so the problem is that these are the same word, they're the same sequence of letters. The fact that I have multiple E's means that some of the things that would normally be different possibilities actually lead me to the same word in the end. And so my answer can't just be 8 factorial, I need to do something a little bit more complicated. Okay, so what do I need to do? Let's go ahead and fill in some blanks here. So I'm going to set up my 8 blank, just like before. And the way that I'm going to approach this is I'm going to go group of letters by group of letters. And so I'm going to first look at all letters of one type. In this case, let's start with the S's. So there are 3 S's here, 3 S's. And what I want to do is I want to construct my rearrangement of letters by placing down those 3 S's into one of these 8 blanks. Another way to say that is to say that, hey, how many ways are there to choose 3 blanks for S's from the 8 possibilities? So I just need to pick, for example, 1, 2, 3 blanks to hold my S's. I don't care what order they're in because all the S's are the same. There's not really such a thing as a third S or a second S or a first S. They're all going to lead to the same sequence. And so when I ask this question, how many ways are there for me to choose these 3 blanks from the 8 possibilities? That's just the binomial coefficient that we've seen before. The answer is that there are 8 choose 3 ways for me to pick S's. So let's go ahead and fill those in. S, S, S. Now I ask a new question. How many ways are there for me to put my E's down? So here are my E's. I have 2 E's, and I have 5 slots that are remaining. So for example, maybe I end up picking these 2 slots to fill in my E's, E, E. And that leads me to saying, hey, I needed to pick 2 possibilities from a set of 5. So I needed to use a binomial coefficient, 5 choose 2. Then, I'm not done, I have 2 L's to place down. L, L. Okay, I have 3 spaces remaining. Maybe I choose this one and this one. So I fill in L, L. And I made a choice of 2 things from a set of 3 things. And then finally, here's my f. There's only one place for it to go, f. And so I needed to pick 1 from a set of 1 possibility. And this is my answer. If we needed to turn this into a number by evaluating all these binomial coefficients, we could. But this is my answer. I had 8 possible places to put my 3 s's. I had 5 possible places to put my 2 e's. I had 3 possible places to put my 2 l's. And I had 1 possible place to put my 1 f. So this gives me my result rather than just using our formula from before, 8 factorial. That's not going to give us the right answer because that doesn't take into account repetitions. We can take the repetitions into account by using the idea of sequential choice along with the idea of binomial coefficients telling us how many ways there are to select slots for each of the types of